viewers. In our session for today, we are going to discuss about the inverse Laplace transform. You can be given a function like this one and then you are being told to find its inverse Laplace transform. The first thing that we need to check is on the denominator. When it comes to the denominator, we are going to factorize the denominator using the complete square method. When it comes to the complete square method, we are going to have s squared, we add to 6s, we add to 13 is equals to 0. To mean that we are going to have s squared, we add to 6s negative. Everything is equals to a negative of 13. For us to simplify this equation, we must introduce our term of c. C, we are going to use the formula of c is equals to b all over 2 everything squared. To mean that 6 all over 2 squared. And here we are going to have 3 squared. This is now the value of c. Let us rewrite everything from this point by introducing the value of c. S squared, we add to 6s, we add to 3 squared, negative 13, we add to 3 squared. On this side, on the left hand side, now we can collect the like terms which are of power of 2, and we are going to have s, we add to 3 squared is going to be equals to negative 13, we add to 9. 3 squared. Here we are going to have a negative of 4. To mean that we can rewrite everything and have s, we add to 3 squared. Here we are having a negative, so we are going to have a positive of 4. And now we are going to have the inverse Laplace transform of 3 all over s, we add to 3 squared, we come and add to 4. When we check at our function here, for us to get now the inverse Laplace transform, you must understand the first shift theorem. When it comes to the first shift theorem, we understand that exponential, positive or negative at, the Laplace transform of this function, cos our angle t is equals to, here the first thing that we said, we must get the Laplace transform of cos. And the Laplace transform of cos is equals to s all over s squared, we come and add to that. But since the term of s will be shifted on this side, we must have a negative or a positive of a to the term of s being shifted, and here also negative or a positive of a, but this one was squared. When we check at this form, it does not match whatever we are having here. You go and check on, you get to check now on sign. the Laplace transform of exponential positive or negative at sine our angle if it can match whatever we are having at this point. Here we are going to have our angle because we must get the Laplace transform of sine t all over s squared. We come and add to our angle squared. The term of s must be shifted, and now we are going to have s negative or positive of a, but this term was squared. When you check at this function here, it's a kind of resemble our function here, but you will find that we must have our angle on both the numerator and at this point. We can now rewrite everything here and relate to whatever we are having on this side, because we are moving from this side, our answer, back to the Laplace transform of our function f of t. Now we can factor out 3 inverse Laplace transform of 1 all over s. We add to 3 squared. We come and add 2. Here we are going to have 2 squared. Yes. We must have our angle at this point and at this point. They must be equal. And how can we do that? We understand that our angle here is equals to 2. We multiply both the numerator and the denominator by 2 to introduce that 2 here. And we can come and have 3 all over 2. The inverse Laplace transform of, we are going to have 2 all over s. We add to 3. Everything squared, we come and add to 2 squared. You will find that whatever we are having here is equals to whatever we are having there. And now we can get into our answer. From this point now we can relate these two, and we are going to have 3 all over 2 exponential. It was shifted with respect to a, and our a here is equals to 3. To mean that here it is a positive. We say that when it is a positive here, we are going to take a negative on the coefficient of a. Here we are going to have the negative 3t sine our angle is equals to 2. So we are going to have 2t. And this is the inverse Laplace transform of the given function that we were given in this equation. This is how you go about finding, and this is how you go about finding the inverse Laplace transform of the function that we were given. Thank you for your time.